Hello, hi, this is Mr. Gagnon again. Let's do a wrap-up. So this is the type of problem that you're going to see that will include everything that we've learned about net forces, frictional forces, and calculating the acceleration of an object. So here's our situation. We've got a man. He pushes a block across the floor. The sliding friction force is equal to negative 100 newtons. And the applied force is 300 newtons. We'll actually put that as a positive because we need to know that that's going to the right, to the block. What's the acceleration of the block if the mass of the block is 12 kilograms? Okay, so let's do this step by step. Okay, so this becomes a problem. We look at it, and at first it looks kind of daunting. It looks a little difficult, but we can break it down into pieces. So step one. Okay, step one. Let's just draw a picture of what's happening here. So it's pretty easy to draw a picture of a block. Okay, the block is on the floor. And we really don't even need to draw the man drawing it, pushing the block, but we can. So here's the man pushing the block. Okay, so he's pushing on that block. And that'll give us an idea of what is happening here. All right, we know that the block has a weight. We know that the block has a normal force. So let's call this weight Fw. Fn is the normal force. Force applied, because he's pushing it to the right. And there's a friction between the block and the surface here, so we'll call this force of friction. Okay, so there's our first step, is we want to just be able to identify what's actually happening. So draw picture. Okay, draw a picture. Okay, there's our picture. Now, what we can do with that picture now, and I'll flip the page so we can look at what's happening here, okay, is we can now say, well, our picture should be represented now by step 2, free body diagram. Okay, or FBD. Okay, so we've got our forces. This is our block now. Okay, this here is again, the weight, force of weight. This is the normal force pushing up, and we realize that the book or the block that we're looking at does not float, and it doesn't sink. So these guys have to be equal, so we're not really concerned about that right now. We have the applied force. We also have the frictional force pulling backwards, okay, pulling against the applied force. All right, so if we have our numbers, okay, originally what we had said was that, I'll bring this back so you can see it. Okay, that a man pushes a block across the floor. The sliding friction, okay, frictional force is negative 100 newtons. The applied force is 300 newtons. Okay, so if I just put the applied here, that's 300, and then the frictional was 100 this way. Okay, I can get a visual of what's happening here. So if I get a 300 this way and a 100 this way, easy, right? What do? We just take the 300, add it up with the negative 100, and we get our net force acting on the block. So let's do the net force. Net force is equal to the addition of these two, which if you know your math, you can say positive 300 and a negative 100 is equivalent to positive 200 newtons. Okay? So 200 newtons of force is our net force on the object. Now, Okay, I'll remove our paper here. Now it says, well, let's bring it back for a second. It says, what's the acceleration of the block if the mass of the block is 12? Okay, so let's write the mass of the block too. So mass of the block is 12 kilograms. Okay, so we've got our information. Now, going back to Newton's second law again, you guys are going to realize we see this law a lot. It says the sum of forces equals to the mass times the acceleration, but we want to find the acceleration here. So, rewriting the formula, acceleration is net force over mass. Okay? So this formula is something that you want to have down, especially when you're looking for acceleration. So let's plug the numbers in. That's all we do here is to plug our numbers in now. Okay, you know what we can actually do is we can get rid of this. We can get rid of this because we've resolved these forces into one net force of 200 newtons. Okay, that's what we did. So don't let these numbers confuse you anymore because we've already done the math to get rid of those numbers. So acceleration is net force over mass, 200 newtons. That's my net force, which I had from this part here, over mass. Okay, so 12 kilograms. Let's check it out. Okay, 200 divided by our 12, and you get the acceleration rate is positive 16.7 meters per second squared. Okay, acceleration is 1.7 times 10 to the 1 meters per second squared. So it's accelerating quite quickly. If you think about what gravity is 9.8. This is 16. This block is moving pretty good. Okay, you got 200 newtons on a 12 kilogram block. Is going to accelerate it pretty quickly. All right, so we have that as our answer. Okay, that is a full-blown problem. That's our goal. I'm going to give you guys a couple of examples to try later on. Okay, so you'll see that up there as well. I'm going to give you guys some examples to try, and then I'll post the answers as well. All right, thank you, and have a great day.